Okay, that's it for me. Thanks very much for coming. All right, let's go ahead and get started. Hope you guys enjoyed that. Much better than what? Much better than this stuff. That was my intro music. So thanks for making me feel bad. Okay, let's go ahead and get started. We've got a lot of stuff to cover. For those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team. And among other things, I write the product documentation for high availability, site resilience, and a bunch of other areas as well. I'm really super excited to be presenting a high availability deep dive for Exchange 2010 to you. Just out of curiosity, how many of you are running 2010 already? And how many of you are directly responsible for the day-to-day management of a database availability group? Okay, how many of you have not yet played with a database availability group? Okay, a couple of hands. All right. So this is a deep dive session. This is a 400 level session. I'll try to make sure that everything I talk about is something that you can understand regardless of what your experience is with the DAG. And as you might imagine, in an HA deep dive session, we're only going to be able to cover so much in 75 minutes. So I've limited the scope of topics. There's much, much more we could talk about besides this, but I've limited the scope of topics to those areas that seem to be sort of the most confusing and the most troublesome, and of course the areas where the inner workings of the platform aren't well known to the admin as well. So I'll start by talking about some recent behavior changes that we introduced in Update Rollup 3 because they pertain to high availability, some of these changes. Then we'll get right into talking about things like DAG networks, Active Manager, best copy selection, and then we'll end up talking about DAC mode, Data Center Activation Coordination mode. At the end of this session, after this is over, about a half hour later is the Ask the Experts in Hall 7. I will be going there after this session, and along with myself, there will be several other folks from the Exchange team who would be happy to answer your questions. So if we don't cover the high availability stuff that you would like to hear about or learn about in this specific session because of the time we have, come and see me at Ask the Experts, and we'll talk about all things related to Exchange HA. So let's talk about some recent behavior changes. These are changes that we introduced very recently in Update Rollup 3, the latest update that we have for Exchange 2010 SP2. And because they are new behavior changes that impact high availability, I wanted to first start by mentioning them. So one of them is a new feature. I'm not going to go into too much detail because Jeff already covered it in his SP2 session, but it is an HA feature. It is a behavior change where when you have multiple sites and users who move between sites or users who roam around, we now have a better experience. So my mailbox is in Redmond. And if I travel around the world and I decide to access my mailbox, say for instance through an EMEA website, I'm going to go ahead, punch in my information, and it's going to give me a message saying you'd actually get better performance if you went to the Redmond site instead of the EMEA site. So I'll click that link, I type in my credentials again, and then I'm finally in my mailbox. What we've changed about that experience is we've removed the need to have that manual link. And we've also added the ability in some scenarios, basically where you're using forms-based authentication, to allow single sign-on as well. So with those changes in place, the scenario for me would then be I point to the EMEA website for my mailbox, I enter in my username and password and click login, and it takes me right into my mailbox. I don't get the manual redirection for the other website, and I have a single sign-on experience because we're using forms-based authentication. So that is one change that we made. And as I said, if you haven't seen Jeff's Inside SP2 session, download the recording and watch that because he talks about this quite a bit. There's also documentation, and one of the PMs who drove this feature, Ross Smith IV, he did a nice video on it as well, so you can view what the experience looks like before and after as well. Also, just as an aside, as I said in my other session, I see a lot of people taking pictures and whatnot, and that's fine. You're totally cool to do that. But the slides will be or are already downloadable, and we're recording this as well. So if you want to just relax and not have to take pictures, that's fine. But if you want to take pictures, that's cool too. It's $5 a photo. Okay. Another change that we introduced, and this directly affects database availability groups, is there's a property called allow cross-site RPC access. And up until update rollup 3, that property did absolutely nothing. It's a Bool property, so you could set it to true or false. And you could set it to true or false all day and all night. It wouldn't do anything until update rollup 3 is. It was part of a feature that we wanted again early on, but we couldn't get it fully implemented, but it was implemented enough where we didn't want to start pulling things out. So up until update rollup 3, that property is listed as reserved for future use by Microsoft. Well, this is the future use. Now with update rollup 3, this property is now usable. And basically, it controls the experience when a user is accessing a client access server and they have their mailbox database located in a different Active Directory site. The control of the experience that the admin now has is whether or not they want to allow that RPC communication between CAS and mailbox to occur over the WAN. Okay? If they want that to occur, they set it to true, and that's the behavior that they get. I talk to the CAS in my site, and CAS will talk over the WAN to the mailbox server in the other site. If they don't set it, they leave it at the default of false, then the opposite is true. If I'm talking to a CAS in my site, but my mailbox is in the other site, I'm going to get redirected over to the other site so that I'm talking to a CAS that's local to the mailbox. That's the behavior change there. That property can now be used as long as you have update rollup 3 installed on all of your DAG members. Oh, there's one other change too. It's actually not super important, but it's worth mentioning. We did have a bug where if you pre-populated the alternate witness server and alternate witness directory fields ahead of time, and then you decided you wanted to null them out, you couldn't do that through our UIs. Now with update rollup 3, you can. Previously, if you wanted to get rid of them, you had to change them to something else, or actually go into ADC edit and remove those properties from the DAG object itself. You don't need to do that now. If you just need to null them out or erase what's there, you can do that with update rollup 3 as well. And one other change that we made, and this is more under the hood kind of changes, so you aren't going to notice anything from an admin perspective, but we introduced a change actually in update rollup 3 as well, where we are modifying how Active Manager behaves when mailbox databases are down and you're going through a dial tone database exercise. So if you're not familiar with dial tone database, it's the ability within Exchange, which, by the way, we've had for many releases of Exchange, the ability within Exchange to bring up a new empty mailbox database and move users over en masse and basically give them an empty database so that you can restore that ability to send and receive, that dial tone metaphor that we use. If you're using that, there was a phenomenon where if the source or the target was down and you wanted to do that dial tone switch, normally it's just a configuration change. You're not moving any data. Users aren't actually being migrated. You're just flipping some information in Active Directory. But we would make RPC requests to the source and the target, and if they fail because they would be down, which is why you're doing a dial tone move in the first place, that would end up adding like 40 to 60 seconds per mailbox. So if you're trying to do 100 or 1,000 mailboxes, that took a really, really long amount of time to do that switch. We changed that. We actually now catch those RPC failures, and instead of waiting for the timeout to occur, we just accept them, catch the exception, and move on to the next one. So now if you're doing a dial tone move with Exchange 2010, update rollup 3, things go super fast now. We've optimized it. Okay, so those are the changes. One other thing I want to point out, because this is a deep dive session, we don't have the time to cover things like quorum, witness, the witness server, the alternate witness server, and some of the other things like lag copies, auto database mount dial, activation preference, et cetera, et cetera. But those are all covered in another session I've done called High Availability Concepts. And that was a TechEd session, so it's recorded and online, and you can go to that URL and watch that and get all the other information, which would normally be considered almost prerequisite information for this session. But as I said, I'm going to try to make sure that everybody understands everything that I'm talking about. So let's get to the meat. So we're going to start with a discussion of DAG networks. So for those of you who are managing DAGs today, raise your hand if you feel like you're an expert in DAG networks. Don't be shy. All right, good. Then this won't be a waste of time. So what is a DAG network? A DAG network, it's a logical object. It's not a physical network. It's a logical object that we create that is basically a collection of one or more subnets. In terms of terminology, there's two types of DAG networks. One is the MAPI network. As its name implies, that's the network over which we communicate with other Exchange servers. It's the network that we have MAPI traffic coming from CAS and Hub and other servers into that mailbox server. It's also the network that gets registered in DNS. It's also the network that uses client from Microsoft networks and file and print sharing. It's also the network that will largely have a default gateway in a routed environment. Now, by contrast, a replication network, as its name implies, is for continuous replication, the log shipping or the seeding. Okay, and it is not registered in DNS. A replication network does not have a default gateway. A replication network does not use client from Microsoft networks, and it doesn't use file and print services as well. It's almost the exact opposite type of network. These configuration differences are important because when you add servers to the DAG, the cluster enumerates that configuration, sends it up to the Exchange stack, and Exchange, based on these configuration settings, will distinguish which network you want to be the MAPI network and which network you want to be the replication network. So if you don't configure your networks correctly, when you add the servers to the DAG, your DAG networks will not automatically be configured correctly. So that's one thing you need to worry about. These differences are not just there because of the technological needs of the protocol that we're using, but they're there because we use them to distinguish between a MAPI network and a replication network based on the configuration settings. Now, what are the requirements? Historically, with highly available mailbox servers, we always wanted you to have 2 network cards in each member. We don't require that anymore. With a DAG, we only have a requirement of 1 network card. Now, all DAGs must have exactly 1 MAPI network. They can't have multiple MAPI networks, only 1 MAPI network. All DAGs can have 0 or more replication networks. So you see now that the replication network becomes optional. It's not required. And DAGs can also have multiple replication networks as well. And if you have multiple replication networks, we will load balance across them. We use a least recently used algorithm to pick the proper network to use for continuous replication. We also will automatically fail over between the networks, and I'll talk about how that behavior works in a minute. Now, the initial DAG networks that you get, those appear automatically once the server is added to the DAG. We install the cluster service, or we join it to an existing cluster. We enumerate the network settings. Cluster passes that up to us. We look at the configuration settings. And for each individual subnet that we find, we create a corresponding DAG network. And that DAG network will be a MAPI network or a replication network based on how it's configured. So, very simple exercise. I've got a DAG with 2 servers in it, EX1 and EX2. Each DAG member has 2 network cards in it. 1 for the MAPI network on 192.168.0 and 1 for the replication network on 10.0.0. So in this case, knowing that I have 2 separate subnets, when I add these servers to the DAG, how many DAG networks do you think are going to be created? Just shout it out if you think you know the answer. I have 2 subnets. How many DAG networks am I going to get? Just shout it out if you know. I hear 4, and I hear anything else? 2. Okay, the answer is 2. Okay, because we've only got 2 subnets. There's a 1-to-1 mapping initially between a DAG network and a subnet. So this is fine. This is how you want it to look. We've got 2 NICs on the 192.168 subnet, 2 NICs on the 10.0.0 subnet. We can see the interfaces reflected in each of the DAG networks. Because the 192.168.0 configuration has the default gateway and the other configuration settings I mentioned, it's automatically got MAPI access enabled set to true. It's automatically been discovered as the MAPI network. By contrast, DAG network 02 on the 10. Subnet, its MAPI access enabled is set to false. It's been identified as a replication network, in part because it doesn't have a default gateway, and in part because of the other configuration settings. Let's make things a little more interesting. Same situation, 2 servers, 2 NICs. Except in this case, I have the servers on different VLANs or in different subnets in different data centers. So the MAPI network for server 1 is on 192.168.0, but the MAPI network for server 2 is on 192.168.1. Similarly, the replication network for EX1 is on 10.0.0, and the replication network for EX2 is on 10.0.1. So knowing now that I have 4 subnets, when I add all these servers to the DAG, how many DAG networks would you expect to be enumerated? 4. That's right. That's excellent. But here's where things get interesting. In this configuration, even though I have 4 DAG networks here, in this configuration, the DAG will replicate only across the mapping network because I need to do some extra work. Here's what the problem is. Don't overthink this question. I have this. What do I need to network it? Don't overthink it. What? A gateway? No, I don't need that. I just want to network this with something else. What do I need? No? I just need the something else. I just need another endpoint. You don't have a network with 1. You need 2 for a network. That's why I said don't overthink it. If you look at the subnets and the interfaces, they all have a single endpoint. None of them have multiple endpoints. We don't have a cohesive, logical DAG network that can be used for replication. And we have a fail-safe mechanism inside of Exchange that says if the system cannot determine which network to replicate over, or if the system can't find a viable logical network to replicate over, it will revert to using DNS registration to figure out how to replicate traffic. Now, going back to those configuration differences, what is the only network that will be registered in DNS? The mapping network, that's right. So in this configuration, even though you've set up the extra networks, it's only going to replicate over the mapping network until you do what I'm about to show next. And that is collapsing these DAG networks. That's the term that we use for taking subnets out of some of the DAG networks and putting them into the other DAG networks. And it's actually a pretty simple process. There's 4 commands that you would run. You can do this in the GUI. It's fully supported inside the management console. Or you can do it in the shell. Now, these 4 commands, because they're word wrapped, I've color-coded them, white, yellow, so you can see where one starts and one stops. So here's what's going to happen. I'm going to run through them one at a time. So I'm going to use the set DAG network commandlet. That's the command I use to manipulate DAG networks. I pass in the identity. In this case, I've decided to keep DAG network 01 and 02, and I want to take the information from 3 and 4 and move it up into 1 and 2, respectively. So I run this first command, and I specified that the subnets for DAG network 01 should be those 2 subnets. I have to include both the subnet I want to add and the subnet that's already there, because whatever I put in this command for the subnets will overwrite what's there. So I want both to be appearing, so I have to include them both. Then I also go ahead, because that's my mapping network, I go ahead and set replication enabled to false. I don't want that treated also as a replication network, because then that least recently used algorithm will kick in. So I'm going to set replication enabled to false and turn that off. But again, we have another fail-safe mechanism. A fail-safe mechanism that says if all replication networks fail, even if replication is disabled on the mapping network, fail over and start using the mapping network. So you want replication to be disabled normally on your mapping network so that it's not used during normal operations for replication traffic, unless that's your intent. Otherwise, just leave that unchecked or set it to false, and then it'll just be a failover network for replication. So I take care of both those things. I'm turning off replication on the mapping network, and I'm adding the subnet to it that I want to add. So I run that command, and I end up with a configuration that looks like this. The interface and the subnet information that was in DAG network 03 has now been moved to DAG network 01. DAG network 03 is now what we would call an empty DAG network. I do the similar thing for DAG network 02. I'm taking the subnets parameter, and I'm passing in both the subnets that I want it to have. Okay, it's a very similar thing. I don't need to mess with the replication network, because this is my replication network. And so when I do that, a similar thing happens. The information from 4 is moved up into 2. Now at this point, I have 2 empty DAG networks, and I simply run remove DAG network along with the appropriate network name, and those 2 disappear. And now I'm left with 2 networks, one that's a mapping network, one that's a replication network, and one in which the replication network will actually work for you. So don't forget to collapse your DAG networks. If you don't collapse them, we will only replicate over the mapping network. Excuse me. Now, when you're using a single oh my goodness, excuse me. When you're using a single NIC, that's going to be both the mappy and the replication network. Okay, so there is no load balancing. It's just one network that you're using for both. I'm losing my voice a little bit. When you're using multiple NICs, one is going to be the mapping network, the other is going to Gosh, I'm really losing my voice. Give me a second. The other one's going to be the replication network, as it says up there. Now, showing you what it looks like in the GUI, here's that enable replication checkbox. That's the same thing as if I set replication enabled to true if it's checked, false if it's not. So you can do all this stuff in the GUI. I could add and edit the subnets. I could change the name of the network, give it a description, and so forth. So what I was saying earlier is even if you uncheck that box that says enable replication, or if you set replication enabled to false, we will still use the mapping network for replication if it is our only way to replicate data. There's a failsafe in there. If you leave the box checked and you also have a replication network, we'll load balance between the two of them. So the behavior choice there is yours as to how you want it to behave. Most customers will leave replication disabled on the mapping network and only use the mapping network for replication in the event of a failure. Now, we do fail over to the mapping network, but we don't fail back automatically. So if there is a failure of the replication network and we do fail over to the mapping network, once you've repaired the replication network, you're going to need to suspend and resume replication. That will cause us to reevaluate the networks that are available and go back to using the replication network. And that is, the easiest way to do it. There's other ways. I mean, you could certainly dismount and mount the database. You could restart the replication service. But those will affect everything. If you just suspend and resume, that doesn't really affect anything other than tell the database to try and use these other networks again. Now, there's going to be possibly other network cards inside your servers. You might be using, for example, iSCSI storage, or you might like dedicated backup networks if you're taking backups across your network as well. Those types of networks, they need to be configured so that they are ignored and not used by the DAG. Because Cluster doesn't know. Cluster just sees the configuration, sends it up to us, and whatever we get, we start using for DAG networks. You don't want us to use your iSCSI storage pipe for replication. Okay, iSCSI should be isolated. You don't want us to use your backup network for replication or mapping traffic. That is also meant to be isolated. That's why you have a separate network. So what you need to do is you simply run the command. It's set database availability group network. Give it the name of the network, turn off replication, and then set ignore network to true. And what this does is that tells the DAG that, yes, we know you see this network there, but don't use it for any purpose. Okay? Don't use it for replication. Don't use it for mapping traffic. Don't manage it. Don't alert when it's up or down, etc. Don't do anything with it. Ignore it completely. And it's a persistent change, so if you reboot the box, it still ignores the networks. There's also the opposite of this as well. There's the ability to discover networks, and you actually use the discover networks parameter. So if you're adding network cards to the system later on, you could run this command with discover networks, and it will find new networks that you've added as well. Now, one of the other important things that you need to be aware of is there are some important routing changes that you're going to want to make in a multi-subnet environment. So obviously, excuse me, one of the first things you want to do is get this KB 246-9100 on there. That fixes a problem with NetSH where persistent routes that you have added disappear or don't show up. You are going to use persistent routes in a multi-subnet environment because going back to the discussion of the networks, remember the replication network doesn't have a default gateway. So how then does it route if it doesn't have a default gateway? Well, static routes. And the static routes you enter are done using NetSH. And so you want to make sure that those routes that you've entered in persist and are there, because if they disappear, again, it's going to revert back to the mapping network. So you want that hot fix on there. Fixes a very important issue. It also includes other fixes that fix other cluster-related stuff, but this is the most important one for DAGs. The next thing that you want to do, and the way you do this is your choice as well, is you want to block cross-network heartbeat crosstalk. So just a quick question. I ask this in all the sessions that I deliver. How many of you are familiar with a heartbeat network in clustering? Okay, wow, lots of hands. Okay, well, then you're in for a surprise because there's no such thing. And there never has been, ever. Why? Because in a Windows failover cluster, all networks are heartbeated. There's no such thing as a heartbeat network. So what's the problem? Well, with the DAG that can expand out to 16 nodes and have multiple network cards, now you suddenly have heartbeat traffic going from the MAPI interface on one server to both the MAPI and the replication interfaces on all those other servers. You don't want that cross-subnet traffic. You only want the MAPI network to be able to heartbeat the MAPI interface on other servers. You only want the replication network to be able to heartbeat the replication interface on the other servers that are part of its DAG network. So if you have multiple replication networks, they should be similarly isolated from each other. How do you achieve this? You can do that through NetSH. You can use router ACLs. You can use several mechanisms to block this traffic. If you don't block this crosstalk traffic, two bad things are going to happen. One is you're going to diminish the system's ability to distinguish between a server failure and a network failure. We want that ability because they may have different implications depending on the network that fails. If a replication network fails, we'll fail over to the MAPI network. But if the MAPI network fails, we trigger a server failover. So we need to distinguish between those differences. But more importantly, if you don't block this crosstalk, you will have all this heartbeat traffic going across all of your nodes at almost all times. And you'll have basically a heartbeat storm occurring. So you want to block this traffic. You have to block this traffic. It's very important. OK. So that's it for DAG networks. Now let's get into the brain of high availability, the component known as Active Manager. So for those of you who've implemented a DAG, you know now that we no longer use the cluster resource model. If you open Windows failover cluster, it has no idea that Exchange is even there. We are now, instead of being a cluster-aware application, we are simply a consumer of clustering technologies. In fact, with respect to the DAG, we only use 3 pieces of cluster technology. We use the node and management APIs so that we can group the servers together. We use the networking and the heartbeat technology so that we can know when servers go up and down. And we use the cluster database to write information so that it can be replicated immediately to all the other DAG members. But because the cluster has no idea that we're there, it can no longer monitor us, and it can't take any corrective action when things go bad. So we had to have another mechanism that could fix things when things go bad. And that's the Exchange component known as Active Manager. So Active Manager runs inside the Microsoft Exchange replication service on every mailbox server. It is a required service for all mailbox servers. Because not only is Active Manager the brain of the HA platform, it is also the gatekeeper for mounting databases. Yes, the information store still does the actual attaching and mounting of the database, but in 2010, it will only do so if asked to by Active Manager. So Active Manager is the gatekeeper. If the replication service is not running on any mailbox server, whether it's a member of a DAG or not, Active Manager is not functioning and databases will not be mountable. So it's an important service to keep running. It's also now the definitive source of where a database is located and mounted. Historically, before 2010, if you wanted to programmatically determine where a user's mailbox was, you could query Active Directory and find that information. But we can't store that in AD anymore, because it changes too quickly now in 2010. With the ability of a database to move between servers within 30 seconds or less, we can't store it in Active Directory because Active Directory replication latency prevents us from communicating that change around quickly enough. However, if you write that change into the cluster database, it is immediately propagated to all DAG members. Okay, so they find out about that change instantly. Now, Active Manager is not just the component running on the mailbox. There's also Active Manager client components as well. There's a client component running inside the Microsoft Exchange RPC Client Access Service on the CAS. And there's a client component running in the transport stack in Hub. And those client components query the Active Manager running in the DAG to find out where the user's mailbox is located, to deliver mail, or to open and render their mailbox through OA or Outlook Anywhere. Now, there's several Active Manager roles. Until I add a mailbox server to a DAG, it will always have a standalone Active Manager role. So Active Manager in a standalone role can't really provide high availability, but it will still do monitoring, and it will still act as the gatekeeper for mounting databases. So even on a standalone mailbox server, you have to have the replication service running. Once a server is a member of a DAG, then it inherits one of 2 roles. It either becomes the primary Active Manager, or it becomes a standby Active Manager. And as I mentioned, the 2 client components as well. So let's talk about the primary Active Manager, PAM. PAM is the linchpin. PAM is the controller within a DAG. Within every single DAG, there is and always will be only one PAM. And it will always be whichever DAG server happens to own the cluster core resources. the IP address, the network name, and if necessary, the witness resource. As those resources move around for whatever reason, due to failures or scheduled maintenance, the PAM role will follow that around. PAM is responsible for monitoring its local information store, monitoring its local databases, but it's also responsible for reacting to all failures. Okay, so if any failure occurs anywhere in the DAG, either the PAM knows about it because it's locally, or the SAM tells the PAM, and the PAM takes the corrective action. It's only the PAM can take corrective action. The SAM, that's going to be on every other node in the DAG, every other node that's not the PAM. And the SAM is there to monitor the local information store, to monitor the local databases, to respond to CAS and Hub when they're querying for the user's information as to where the mailbox is located, and of course to notify the PAM when there's a failure that needs to be corrected. Now, as I mentioned, both roles are necessary for automatic recovery. If that service isn't running, you don't have recovery, you don't have an operating DAG, you don't have continuous replication, and you don't have mounted databases. It's a critical, critical service. So that begs the question, how do you find out what server is actually the PAM? Well, there's one way to do it is you could run the getDAG commandlet with the status parameter. That's a parameter we have for some commandlets. When you add the status parameter, that's going and getting extra information that you don't get back without the status parameter. It's a bit more of an expensive operation when you use the status parameter, but it's the only way within the exchange commandlets to find out where the PAM is. You can also query the cluster, find out which node owns the default group, and that will tell you who the PAM is that way as well. And if you need to move the PAM, you can use either of those cluster commands. The top one for Windows 2008 R2, that has PowerShell support. The bottom one will work on R2 and 2008 SP2. Why is the PAM so important in terms of its location? Because it provides the administrative interface for everything that you do inside the shell and inside the console. Any of the commandlets that you run with respect to HA are interfacing with the PAM. And it's all RPC communication as well. So if your DAG is extended across multiple sites and you're sitting in Redmond, but the PAM role is held by a server maybe somewhere in Europe, that's going to be RPC activity going over your WAN for your administrative functions. You might not like that. That might slow things down depending on how beefy your WAN links are. You may need to move the PAM to somewhere geographically closer to you for administrative purposes. Now, anytime you add the server to the DAG, or anytime the PAM role changes, all of this transition information is logged into an area of the Windows Event Viewer known as the Crimson Channel. So you can see what the path looks like there. It's the Microsoft Exchange-high availability/operational event log. And the Crimson Channel is an area of the event viewer. I'll show you that in a minute in case you haven't seen it. And you can see what some of the events look like. So here's Active Manager. It's been running on a standalone server for, in this case, 3 days. I haven't added this server to the DAG yet, so it's a standalone role. Then I add it to the DAG, and that configuration change is detected. It's changing from standalone to PAM. Then it becomes the PAM, and then it's been running as the PAM for so many times. So each iteration in the process, as we transition through that state, we're logging and tracking all of it. And similarly with the SAM, here you can see I'm adding the second server to the DAG because there's already a first server, and that first server by default has the PAM role. Any additional servers that I add at this point become the SAM. And so you can see what that looks like. Then, of course, I could change the PAM. I could move the PAM role by moving the cluster group. We'll log that as well, changing from SAM to PAM. So what sort of things does Active Manager do? Well, I mentioned earlier it's responsible for mounting and dismounting databases. It will issue those commands, and that's the only way to do it. It will provide database availability information. So if you run the commandlets that show health and status information, that's coming from the PAM. As I said, it provides the administrative interface for the tasks. If you're using the shell or the console, which also uses the shell, you're talking directly to the PAM via RPC. It maintains all the database and server state information. So if you were looking at copy queue status, replay queue status, etc., all that is maintained by the PAM. And it monitors for failures and initiates that recovery as well. So let's talk about how it does those things, starting with the database star over. So if you don't know, star over is shorthand notation. It's short for switchovers and failovers. A failover is automatically done by the system. A switchover is manually performed by an administrator. We call those collectively starovers. So a starover, that always will begin with Active Manager doing a dismount operation on the original active copy, and it will always end with Active Manager doing a mount operation on the copy being activated, on the passive copy that you were turning into the active copy. The mount database, that can be the action that is invoked by the administrator. You can go and right-click on a database and say mount database. You will, at that point, be talking to Active Manager, and Active Manager will invoke the dismount command and also do that as part of the database starover. In dismount database, it's going to be the first part of a database switchover. It's not going to be a starover because a dismount is not something that happens in a failover scenario. So that's switchovers only. Failovers are the unexpected failures. They don't involve graceful dismounts. Now, there's also a function called auto dismount. And this is actually the one and only exception to the rule that says SAM can take no corrective action. Okay, so auto dismount is a function that happens on all DAG members when they lose quorum. Because obviously, quorum is required for a DAG. If you don't have quorum, we need to terminate and dismount everything and stop operations. So that's what auto dismount does. It's possible that the DAG members are running. It's possible that the cluster is running. It's possible that the replication service is running. And that largely things are fine, but you've lost enough votes where you've lost quorum and things are going to instantly terminate. At that point, what's going to happen is all of the Active Manager roles, excuse me, including SAM, will immediately terminate the store process, causing a forcible dismount of all databases. This is the only instance where we allow SAM to take corrective action. And of course, we had to do that because if it's the SAM that's on a system that's lost quorum, it's lost its ability to communicate with everything else. So we wanted to hard shut down at that point, and that's how we affect that. Now, I mentioned the Crimson Channel. That is a Windows, excuse me, a Windows Event Viewer feature. So if you've been in the new Windows Event Viewer in Windows 2008 or 2008 R2, then you've probably seen the Crimson Channel. Let me show you a picture of what that looks like. So I'm showing you two things. Up at the top, first I'm showing you where we had this filter that we pre-populate, the Microsoft Exchange with Database Availability Group events. That's a pre-canned filter that we populate in Event Viewer on all mailbox servers that are members of a DAG. So that gives you one big consolidated view of all the events on your DAG members that you need to be aware of. So you don't have to go digging through the logs. If you wanted to, though, you can see lower under Applications and Services logs, that is the Crimson Channel. So you can see Microsoft Exchange, High Availability, and then there's several underneath. The only channel that will really be of use to you is going to be the operational channels. The other channels that are there are largely for the application. Because the Crimson Channel isn't just eventing for the administrator, it's also eventing that is designed for developers to have their application components communicate with one another. So, as an example, when I have an underlying storage problem affecting my database, the first thing that's going to happen is ESE, the Extensible Storage Engine, is going to notice that. It's going to try to write to or read from the database, and it's going to come up with some error. When that happens, the ESE component itself is going to log a warning or error event inside this Crimson Channel area. Active Manager monitors the Crimson Channel. And when it sees that event, that's how Active Manager finds out about storage problems. And then it executes a recovery action, fails over to another copy of that database, and maybe alerts the administrator in the process as well. So we are filling this with information that Active Manager is then consuming and using as part of its data to do the corrective action processes that it does. So this is what the operational log would look like. If you go into the other ones, like the debug, the truncation debug, the block replication, feel free to. You're not going to understand any of those events. They're very cryptic events. You need the symbols and some of the developer source code in order to actually interpret those events. You're going to see weird numbers and stuff, and it's not going to be anything that's meaningful to you. It's only the operational channel that will have any meaning for an administrator. And it's nothing, by and large, that you need to monitor or create alerts based on, because most of what goes in there, it's already being reacted to by the system in the first place. But it is an area where if if you wanted to see what was happening, why did this thing fail over, and more importantly, why did it choose this database versus that database, that's some of the information that you can get out of the Crimson Channel event logs in the operational channel. Now, arguably, the most important thing that Active Manager does is a function called best copy selection. So let's walk through what that is. So best copy selection is what it sounds like. It's the process of finding the best copy to activate in response to either a failure affecting the active copy or in response to an administrator doing what is called a target list switchover. A target list switchover is where I say, I want to move this database or all the databases on the server to somewhere else, but I'm not going to tell the system where that somewhere else is. I'm going to let Active Manager choose which copies to activate for me. That's a target list switchover. A targeted switchover would be move database A from server 1 to server 2. I've said server 2 is my target. Now, Active Manager selects the best copy, and we use quotes there because best is relative. But it selects the best copy to activate based on a set of criteria, the nature of the failure, and some of the conditions around the failure as well. So let me walk you through how it goes. The steps for best copy selection are actually different depending on whether you're running RTM or SP1. And specifically, it's only the first step that is different. If you think about the process that Active Manager goes down, you can actually boil it down to 4 steps. So these are the first 3. It's only going to be the first step that will change. But in RTM, the way it works now is that when we have a failure that affects an active copy of a database, we look at all the possible passive copies that we have to activate them, and then we sort them based on their copy queue length. The copy queue length is the number of log files that didn't make it over from the active to passive. The copy with the lower copy queue length goes to the higher of the list. Okay? The lower copy queue length means it's more up to date. It has fewer missing log files. Now, if we happen to have multiple copies that had the same copy queue length, 2 passive copies, both missing 5 log files, we will break that tie using another property that every database copy has called activation preference. Activation preference is just a number assigned to a database, 1, 2, 3, 4, etc. It's always going to be equal to the number of copies you have of the database. And what we'll do to break that tie is we'll look at the activation preference value for those copies, and whichever copy has the lower value, we will move to the top of the list. Okay, and that will be the one that we'll select to try and activate. Once we have our sorted list, then we look at the one that meets the criteria, and we start the activation process. The activation process starts with this run attempt copy last logs, or this ACL process. That is a process whereby Active Manager goes back to the original active copy and tries to copy any missing log files. So if I have a copy queue length of 5, there's 5 missing log files that Active Manager would like to try and get. So he's going to try and copy them and get them over. Maybe he'll succeed, maybe they don't. We don't know. It's based on the nature of the failure. So those are the first 3 steps. Now, in SP1, step number 1 can be different. Step number 1 can be different if you set a setting on the mailbox server known as auto database mount dial to a value of lossless. So how many of you are familiar with auto database mount dial? Okay. So if you're responsible for the database management of a DAG, you absolutely need to be familiar with this setting. The auto database mount dial is a setting on every mailbox server that controls whether or not Active Manager can mount a database based on the number of missing log files. If you think about an Exchange database, historically, before Exchange 2007, if you were missing log files at the end of a log stream, you did not have a database that you could mount. You had to either find those missing log files, restore them from backup, or you had to do what was known as a hard repair of the database, which was basically your way of carving out the database's need for those log files in order to mount it. In 2007, we introduced this feature called Lost Log Resilience, LLR. And we companioned it with a dial setting called Auto Database Mount Dial. And together, we gave the administrator the ability to say that, yes, I will allow this database to be mounted with a little bit of data loss. I will accept the greater uptime of the database versus having all of my data. That's a trade-off you get to make. So there's different settings for the auto database mount dial. One is lossless. The lossless setting is the administrator's way of saying, I will tolerate 0 logs lost. If there's a failure affecting my active database, do not mount this passive copy unless all log files are present. Okay, that's the lossless setting. The other settings are good availability and best availability. Good availability is 6 or fewer log files missing. Best availability is 12 or fewer log files missing. 12 or fewer is obviously more missing log files. If you're wondering why we call that best availability, it's because we're referring to the availability of the database itself, not the missing data. Hey, again, the administrators can now make a trade-off. You can decide that, yes, I'm willing to accept a little bit of data loss if it means that I can get this database up and mounted and running and servicing them so that I don't have to restore it from backup. But what about those missing log files? Well, as luck would have it, we also have a feature inside the transport stack in Hub Transport called Transport Dumpster. And so any email message that is sent to a database that's replicated in a DAG, we keep a copy of that in the Transport Dumpster. And the Transport Dumpster is plugged into the replication pipeline so that once all the log files have been replicated representing that message, we'll truncate that out of the Transport Dumpster. But we're talking about missing log files that haven't been replicated, which means the data from those missing log files is going to be recoverable automatically by the system through that Transport Dumpster mechanism. So if you do have a failover that's lossy, missing 5 log files, maybe representing 5 megabytes of mail data, after that new active copy is activated, it will reach out and request those messages from Transport Dumpster. So even though we've been talking about this trade-off, it's not a real trade-off because the data that you would normally lose by missing those logs is largely recoverable through Transport Dumpster. Now, getting back to we'll have time for questions. Getting back to the step, though, the difference that we do in SP1 is when you set auto database mount dial to a setting of lossless on all of your mailbox servers, instead of sorting by copy queue length, we now simply sort by activation preference. Obviously, if you've said lossless, it doesn't matter if we sort by copy queue length because you will only tolerate a copy queue length of 0. So now we're going to actually interpret your intent more the way we should have in RTM perhaps by using activation preference and giving it more weight based on the administrator's dial setting. If you don't have the dial set to lossless, then step 1 is the RTM behavior. That is the only change between SP1 and RTM with respect to best copy selection. Otherwise, the second step is the same and the third step is the same. And then at the end, the fourth step is the same as well. Once that ACL process is done, maybe it succeeded, maybe it didn't, then the next question that Active Manager has is the database mountable? And that question is answered by figuring out is the current copy queue length within that auto database mount dial threshold. If we're within the dial range, then the answer is yes, and Active Manager will issue a mount request. If we're outside the dial range, then the answer is no. Active Manager won't issue a mount request, and instead we'll go back to that sorted list of databases and try to activate the next one in the sorted list. So that was a lot. So let me make it simple for you. First, here's the list of criteria that we used, and you can see we sort of degrade the criteria. So the best of all worlds with passive copies is finding a passive copy that has a copy queue length less than 10, a replay queue length less than 50, and a healthy content index. If we can't find a passive copy that meets that criteria, we'll degrade the criteria a little bit. Same copy and replay queue lengths, but maybe we'll look for one that's crawling the content index instead of healthy and up to date. The content index, is the search that's used by online clients. So in this case, the acceptability is, yes, we've got the database online with all the data, but the search experience might be impacted because the index is still crawling. And then you can see with 3, 4, and 5, we'll drop copy queue length and focus on replay queue length. Then with 6 and 7, we'll drop replay queue length and focus on copy queue length. Finally, we get down to 10, and we're like, just give me any database copy with a status that is activatable. At that point, if we can't find any copies in the sorted list that match any of these criteria, that's when the system will stop and notify the administrator that they have to intervene. So let me oversimplify this for you. Very simple scenario. We've got a 4-member DAG. Got an active copy of my database on server 1 and passive copies of the database on servers 2, 3, and 4. Conveniently, the activation preference values for those are also 2, 3, and 4, matching the servers. You can see what the copy queue and replay queue lengths are and the health of the content index and database. So we have a failure affecting the active copy. Now Active Manager invokes the best copy selection process. How does it do it? It sorts the list. So we've got 3 copies in our sorted list. the copies on 2, 3, and 4. In RTM, we're sorting them initially by copy queue length. So if you look, which one has the lowest copy queue length? Server 3. So server 3 is at the top of the list. Server 2 has a copy queue length of 4. That's the next highest one, so it's next. And server 4 has the biggest copy queue length, so it's at the bottom of the list. We don't have to break any ties by activation preference because we don't have any ties to break. We just sort the list like that. Now, of our sorted list, only 2 of the copies on the sorted list meet that first criteria for activation. Only 2 of the copies on the sorted list have a copy queue length less than 10, a replay queue length less than 50, and a healthy content index. It's servers 3 and server 2. So, because server 3 is highest in the list with the lowest copy queue length, it's tried first. Active Manager tries to activate that first. But again, we don't know what the nature of the failure is. The failure might be somebody rebooted the wrong machine, or somebody accidentally pulled the power cord. It might be a simple failure where the server's actually going to come up in a pretty good state in a very short amount of time. So it might be while the system is trying to activate server 3, the actual original server comes back up, and it's able to get all the missing log files, and it actually is able to do a lossless activation of the database on server 3. Now, of course, the nature of the failure could be much worse. It could be that the underlying storage that was hosting the database is gone, which means the database and the log files are gone as well. So that would be a lossy failover. We still might be able to activate the one on server 3. We don't know how that's going to go yet. It's going to be based on the nature of the failure. Now, let's do the same exact scenario, except now instead of RTM, we're running SP1. And we have our auto database mount dial set to lossless on all the servers. So the only difference here, everything is the same. We still have the same failure. The only difference here is, again, instead of sorting by copy queue length, because we're on SP1 and because we've got the dial set to lossless, we now sort by activation preference. So the sorted list is different now. Instead of 3, 2, 4, it's 2, 3, 4 because 2 has the lowest activation preference. And so that one is going to be tried first. So Active Manager will try to activate that. But in this case, we're in a lossless setting, which is why we're going through this exercise, which means the ACL process, the process that goes back to server 1 and gets those, in this case, 2 missing log files that, 4 missing log files that server 2 needs. If the ACL process isn't successful in doing that, then server 3 is going to be tried next, okay? Because you've said it has to be a lossless activation. If server 3 can't get all the log files, server 4 will be tried next. If server 4 can't get all the log files, the database will stay dismounted, and the administrator will have to intervene in order to activate the copy. Now, as I mentioned, after a copy's been activated, there's a bunch of stuff that happens. Obviously, the passive copy becomes the new active copy, starts generating log files using the same log generation sequence number stream that it was carried off from on the last one. That means when the old copy, the old active copy, if it's salvageable, if it comes back up, it's going to need to go through a process called incremental resync. That's a process where Exchange will go and look at the 2 copies and try to figure out if it can reconcile the divergence between them. Go into the old active copy and perhaps remove pages that were never replicated over to the passive copy, and then take the log files that have been generated by this passive copy that's now an active copy and move them over and resync it. So it could be, based on the nature of the failure, that yes, you had a bad failure, but when the old active copy comes back up, it resyncs itself and turns itself into a very healthy passive copy. Again, though, the nature of the failure might be all storage is gone, the database caught on fire or whatever, and it's just gone. And in that case, the administrator would have to reseed a new passive copy. Then, as I mentioned earlier, the other thing that happens with any database or server failover is the new active copy will reach out to the transport dumpsters, both in its local Active Directory site, and if this was a cross-site failover, the original Active Directory site, and re-request delivery of missing messages from that transport dumpster mechanism. So the data that would be normally lost as a result of missing those log files is collected back and comes back in the system that way. There are a few things that could be lost, though, but these are things that are very easily recreatable through user actions. Somebody accepting a meeting request, for example, or someone marking an item as read, for example. Those kinds of things don't manifest as messages that go through transport, so we can't get those physical changes back. It would be up to the user to recreate those. But all the messages, representing those missing log files. Those we do get back from transport dumpster. Okay, the last thing I want to talk about is data center activation coordination mode, or what's also known as the mommy may I mount bit. Okay, that is its actual name. In fact, a little history on that. When we were coding this, that was the name that we gave it internally, and you'll understand why it has this name once you see how DAC mode works. But as a writer, obviously I can't document something called the mommy may I mount bit, in part because it's not really a technical term, but also in part because it's not localizable. Okay, what is the equivalent in German or French or Spanish or any other language? There is none. So we had to come up with a new name. And that's when I came up with the name Data Center Activation Coordination Mode. That's where DAC mode came from, is I needed a better name than mommy may I mount. So it's nothing more impressive than a little bit that we flip in memory. Now, how does it work? Well, how many of you have extended your DAG to multiple data centers? Okay. So DAC mode, and I know you've probably heard and read a lot about DAC mode and all the magic and mystery and free unicorns it provides. But the reality of it is it was designed for one specific scenario and only one specific scenario, which I'm going to show you right now. I have my DAG. It's extended between two data centers. It's a 4-member DAG with 2 members in the primary, 2 members in the secondary. As with all DAGs that have an even number of members, I also have a witness server. I've placed, per best practices, my witness server in my primary data center so that my primary data center has the majority of votes, so that if the WAN goes down, my alternate data center, my standby data center, loses quorum and goes down, but my primary data center stands up. So here's the scenario. I've got my DAG, I've enabled DAC mode, and now we have a horrible failure affecting the primary data center. A giant red X has crashed into our data center, and now it's down. It can happen. So what happens in this case, because we've lost the majority of voters in the primary data center, what happens to mailbox 3 and mailbox 4? Do they stay up or do they go down? That's right, auto dismount. Comes in and says, oh, lost quorum, terminate. So they go down. Now, you've got a decision to make. Are you going to sit here and have your entire messaging system be down? Or are you going to do a data center switchover? I vote for switchover, so that's what we're going to do. So I activate my secondary data center. I run a couple commands. I run stop DAG to go ahead and mark my failed members over there as down. I run restore DAG, which goes ahead and shrinks the underlying cluster and hydrates that alternate witness server and gives me enough votes to regain quorum and bring these guys up. Okay? We still haven't done anything with DAC mode yet. This is still just regular clustering quorum type stuff. Now, things are running fine and we're ready to restore service to the primary data center. So we go ahead and we get power up and running, and those servers come up. But we don't yet have the WAN up and functioning yet. Now, these servers, MBX1 and MBX2, they still have that witness server over there. And they were down. They have no idea whatsoever that a data center switchover has occurred. All they know is they were off, and now they're on. And by their count of the votes, they have quorum. This is where DAC mode helps you. DAC mode prevents something really horrible from happening in this case. Remember, a quorum is required for you to have DAG operations. We need quorum to mount databases. If you have quorum, you should be able to mount databases, right? Maybe. That's where DAC mode comes in. The way it works is DAC mode is this bit in memory. It's either a 0 or a 1. And it's held in memory inside Active Manager, which means it's in the replication service. If you stop and restart the replication service, we reset that bit back to 0, and it needs to change to 1 in order to mount databases. So the rules say that if DAC mode is enabled, a starting DAG member can only mount its database if it can communicate with all other DAG members or if it can communicate with a DAG member that has a bit set to 1. In this scenario, we've got MBX1 and MBX2 that have started up. But they can't communicate with all DAG members. The WAN is down. And they can't communicate with another DAG member that has the bit set to 1. So their bit will stay at 0 and they will not mount databases. Without DAC mode, they would come up, see that they have quorum, mount their database, and create a condition known as split brain. Split brain is where you have the same copy of a database mounted on 2 different servers. Okay, that is very, very difficult, if not impossible, to recover all of the data in a split brain scenario, which is why we want to avoid it in all cases. And this is the one and only scenario where you have the ability for split brain to occur, which is why this is the one and only scenario where DAC mode applies. And this is also all that DAC mode really does for you. So it's a property of the DAG. You use set DAG to set it. It's like a switch that you turn on and off. Generally, we might recommend that you go ahead and enable it for all DAGs. But we do also have a third-party replication API built into Exchange 2010 that third-party vendors can use their replication technology instead of continuous replication if you want. If you are using the third-party replication API, you'll check with your vendor as to whether or not they support DAC mode. If you're not using the third-party replication API, which 99.99% of our customers are not using it, then you should be safe to put your DAG in DAC mode, even if your DAG is not extended to multiple data centers. It's okay. It's not going to harm anything if it's in DAC mode. And as you saw from the scenario, DAC mode is simply an application-level form of quorum. We want to ensure that when a DAG gets severed, and we activate the half without quorum, that the other starting half that still has quorum doesn't come up and mess things up. Because that other starting half was down, and they have no idea that their entire world has changed. And they won't know until they can successfully communicate with the other DAG members. Now, there is a side effect to DAC mode, and the side effect is when you do a data center switchover and the switchback process, instead of having to use cluster commands, you get to use native Exchange commandlets. Whoop-de-doo. Okay, it's not that big of a deal. Either way, the process is almost identical. It's the same number of commands. It's just different letters you will be typing in. So whether or not you see that as a benefit, it's up to you. But largely, the benefit is this preventing of split brain in this one and only this one scenario that you've just seen. Now, how does it work? Well, it uses the Data Center Activation Coordination Protocol, another fancy name that I made up so I'd have something to describe to you. It's internally known as the Mommy May I Mount bit. And if you do any tracing, if you run our Xtrace tool and you trace what Active Manager is doing, or if you look in the Crimson channel, you are going to see references to the Mommy May I Mount bit every time we go through an auto consensus process that determines whether or not a starting DAG member can mount. Okay, so it's in the code. I wasn't going to go in and change the code. Everything's fine. But the documentation will always say DAC-P and DAC mode. So that's the little history for it. So you know the two values. It's in the replication service. As that service is stopped and restarted, the value resets back to 0. And then it's got to go back to 1 in order to be able to mount databases, assuming auto consensus is true. Just because a DAG is able to communicate with all the other servers and maybe has quorum doesn't necessarily mean that auto mount consensus will be true. There may be other reasons that a DAG decides not to automatically mount its databases. So the startup sequence is when you start the replication service, Active Manager initializes it. Part of the initialization process is setting that bit to a value of 0 and then looking at a list that is maintained by DAG members called the started mailbox servers list. Now, during normal operations, any DAG member that is up and running is a member of this list. When you run the stop DAG commandlet, because you're doing a data center switchover, you are marking failed DAG members as stopped, and you're taking them off the started mailbox servers list and moving to the stop mailbox servers list. But during normal operations, all the DAG members are on the started mailbox servers list. So to get from 0 to 1, a starting DAG member either has to be able to contact everybody on that list, or it has to be able to contact, like I said, any other DAG member that already has its bit excuse me, set to 1. If it can't do either of those two things, the bit stays at 0 and databases will not mount. Okay, that's how it works. Now, there's some side effects to that as well. Okay, if you enable a DAG for DAC mode and you decide that you're doing maintenance on the DAG and you shut down all of the systems, you will not see the database auto-mount when you've reached a majority. The databases will actually not auto-mount until you re-bring up all of the DAG members. Okay? That's going to be important. That's an important distinction between a normal maintenance process and the data center switchover process. The data center switchover process is pretty much lockstep. I mean, there's no way to get out of sync with it. But in terms of shutting everything down, everything has to come up and be able to talk to each other because they're all going to be on the started servers list. You're not, when you take things down to do maintenance, you're not running stop dag, you're not moving anything to the stop list. So what that means is even if you bring up the majority of voters, they're still not able to communicate with everybody on the started servers list until you bring them all up. So that's one side effect of enabling DAG. Not a big deal, but it does catch some administrators off guard. They don't understand why their databases don't mount even though they have quorum. You have to wait until you have all the members up in that case. The other nuance to be aware of, and this is something else that catches administrators off guard, is what happens when you have a single surviving DAG member in that secondary data center. So in my example, we had 2, but what happens if you're down to 1? Well, here again is the exception to the rule. Normally the rule is it's only DAGs that have an even number of member will use a witness server. But when we're down to a single survivor of a DAG member, we will, in a data center switchover scenario, go ahead and use an alternate witness server. But we won't use it the way quorum would normally use witness. We're not doing an is alive type thing. Instead, what we're doing is we're actually using WMI to get the boot time of the witness server and the boot time of the DAG member. And we're comparing those two together. And the reason we compare them is we want to make sure that they match the actual boot time that the system records. Because, believe it or not, the boot time will actually tell us the administrator's intent. If the administrator, for example, has rebooted one server but not the other, that's probably some maintenance that they were doing. But if they rebooted both that single survivor and the witness server, then there may be other problems that they're dealing with for them to take down all survivors. So in that case, when we see that both the timestamp, the boot timestamp on the witness server doesn't match and the timestamp on the DAG member doesn't match, we won't automatically mount databases. So if you're the administrator and you've rebooted them both, expect that condition to occur. You just need to go in and manually mount the databases. That's the only nuance there. Okay. So with that, that's all we have here. I do have, looks like, some time to take questions. Let me just verify that there. Yeah, we've got about 8 to 10 minutes or so to take questions. There are no microphones in the room, I don't think. So if you do have a question, just raise your hand and try to shout it out. I'll call on you and I'll repeat it. And then also, please, if you don't have any questions now, feel free to contact me afterwards with any exchange questions. Also, don't forget there's the Microsoft Exchange Conference where we're going to be talking about Exchange 15 in September. And there's still lots of related content as well. Please don't forget to fill out your surveys for the session as well. That's very important. And as I mentioned, right after this session, I'll be over to Ask the Experts to answer more questions as well. So let's start over here with you. Oh, thank you. Thank you. Yes.
I have a question regarding that.
Yes.
Let's assume we have just one data set. Would it be risky to enable that mode in that scenario? Because let's assume I have a maintenance mode with one server, and on the existing three, the phone number that, a real failure appears. Wouldn't it then be the case that the database won't mount?
Sure. So the question is I have a DAG in a single data center, and could there be any harm in enabling DAC mode? I'm just going to shorten it to that because the answer is no. There's nothing that DAC mode can hurt whatsoever. The only time you ever need to be concerned about whether you should enable it or not is, again, if you're using that third-party replication API. There are advantages to enabling DAC mode for a DAG that's in a single data center. And the advantage is, again, if you lose the majority of your DAG members, you're still doing a DAG recovery operation. It's not a data center switchover because you don't have another data center to move to, but you're still doing similar things. So in DAC mode, you still be able to use stop DAG, for example, to mark those members as failed. Instead of using the Active Directory site parameter, though, to say this site is failed, you would use the mailbox server parameter and list the individual members that are down. Then you'd run restore DAG, get the survivors up and running, and then once you've fixed whatever problem affected the failed ones, then you would do the switchback command, which is start DAG, and reincorporate those failed members. So the benefit would be, again, you get to use our commandlets for the switchover and switchback instead of having to use the cluster command. Yes?
If a database is switched and I lost some log files, you said that the mails coming from the lossy mails come from the transport system.
But what's about calendar entries and notes and so on?
Great question. So the question is, in a lossy failover, we get messages back from transport dumpster, but what happens to things like calendar items and notes and whatnot? So any physical changes that are made to the database that manifest themselves as log files, and that includes things beyond mail messages, that will be in the transport dumpster, and we will get that information back. Any physical changes made to the database that doesn't manifest as log files would be lost data. So there are some scenarios where that could include notes. There are some scenarios where a calendar item wouldn't go missing, but it may be altered. For instance, like I said, you might have to re-accept a meeting request. Or there might be an instance where an item that you previously had marked as read is now, for whatever reason, marked as unread, and you have to revert that change as well. But otherwise, anything that manifests itself goes through transport in a log file. We will go ahead and get that back for you.
If I create a calendar entry, it will be written to the transport doctor.
Only if you're sending a meeting request or scheduling a meeting. If you're just creating a calendar entry on your own calendar, that does not go through transport dumpster. So that would fall into the category of reclaiming that through user repeating the action for the user recreating the calendar item. I'm sorry, what? Yes, it will try and copy the log files, but his scenario is the log files are gone. What can I get back from transport dumpster? Yes? Mm-hmm. Mm-hmm. Yep. Yes. Yeah. Yeah, great question. Yeah, so the question is, what about public folders? We've been talking about mailbox databases. What about HA for public folders? Well, you probably know that every DAG member can host a public folder database, but we no longer use continuous replication to replicate them, only public folder replication. There's also no public folder database failover mechanism. The public folder database ends up being tied to the original mailbox database. So there is some extra work that you need to do after the data center switchover is done to go ahead and change the public folder database for those mailboxes databases to point to the ones in your secondary data center. Yes, if you don't do that, then you won't have access to FreeBusy, and your Outlook 2003 clients, for example, won't be able to connect. So there is extra work that you need to do with public folders. Mm-hmm. Right. Right. So the question is, we talked about the ability to move databases across data centers, and what about this RPC client access array property? Do I need to update that if I want them to access in that? So no, you don't. There's very few scenarios in which you need to update that property on that database. Really all Outlook and some of the other protocols care about is that they have a valid endpoint. In fact, Outlook in particular, if it has a valid working MAPI endpoint, it will continue to use that endpoint. If it doesn't, then it will try to find what its endpoint should be through AutoDiscover or some other mechanism. So in the case where the endpoint goes down, that's going to trigger that client to go do an AutoDiscover request, find the new endpoint, and move it over. Now, what happens, though, in a data center switchover, it's not changing names at all. You're just changing the underlying IP address for that URL. So in that case, once Outlook has picked up the DNS change, then it just goes right into the new endpoint. Yes?
When I place up the database on a touch server, is it expected that the client will lose the connection to the mailbox for a while?
Sure. So the question is, if I move a database between mailbox servers, Does the client lose the connection to the mailbox server? No. Clients, we don't allow any client connections to the information store anymore. In 2010, we have rewritten and abstracted the MAPI and directory endpoints away from mailbox and moved it over to CAS. So on CAS, there's two services. One is the RPC client access service. That's the new MAPI endpoint. And the other is the address book service. That's the directory endpoint. So all Outlook clients are going to connect through a CAS array to one of the CAS servers, to the RPC client access service. And then that service will talk MAPI RPC to the information store. So we only allow MAPI logons to the information store from other Exchange servers now. So the answer is the mailbox can get moved a whole bunch of times and it's not going to disconnect the client because the client is connected to CAS. Now, the client might get a pop-up because CAS can't connect to the mailbox for a moment that says, I'm trying to connect to your mailbox. But, if the client is in cache mode, they're just going to see the bubble and it's going to be, hopefully transient and short-lived, and it shouldn't cause them any problems. If it's going to be a large outage, then you would want, obviously, a replicated database, and you would just switch over the database and keep everything up and running.
The issue is that because we are using these outlets very often not as mode, and that's why they lost all
Right. Yeah, an online mode client is going to be more sensitive to that because it's expecting to be communicating at all times with the store. So you'll see that transition into an offline state, and then once the connection is restored, it'll transition back to an online state. So it really depends on how long that mailbox database is down. Yes?
Is it a problem to run the DAG network on the same network as the MAPI network?
Sure. So the question is it a problem to run the, I'll use your words, the DAG network on the same subnet as the replication network? So I'm using your words to try to clarify stuff for you. A replication network is a DAG network. It's one of two types. So what you're really asking is it okay to have the MAPI and the replication network on the same subnet? The answer to that is no. No. Cluster doesn't like it and we don't like it. Every network interface that you put inside of a clustered system has to be on a separate subnet. If cluster sees multiple network cards on the same subnet, it will only enumerate one network out of them. It will ignore the other network. So if you want separate networks, if you want a MAPI network and a replication network, you're going to have two different subnets. If you have to have all the networking on the same subnet, you're just going to have a single network in that case. That'll be both MAPI and replication.
And also, do you have any problems about the HP networking cluster?
You mean like teaming? Okay, so the question is about network teaming. You can team the MAPI interface. You would be teaming it in fault tolerance mode only. You wouldn't be teaming it in load balancing mode. And you could also team the replication interface, but since we support multiple replication networks, it would be preferred and less expensive and less complex if you just use the native failover capabilities that we have in the application layer. And because when the MAPI network dies, we trigger a server failover, so that's a slightly different case. When the replication network dies, we can fail over to the MAPI network. So if you didn't want a failure of the MAPI network to trigger a server failover, then you could team that network. But our intended behavior is when the primary network on the server dies is to have the server failover anyway. So you would just be sort of masking that behavior. And it may not even do you any good. It could be, unless you have complete redundancy, not just at the teaming level, but at the cable level, at the switch level, at the power level, et cetera. You could find that, you could do all that teaming, and it still doesn't do any good because some failures take out the entire server anyway. So I would say keep things simple and complex. Don't team the MAPI network. Don't team the replication network. If you must do it, it is supported, but only in fault tolerance mode. Yes? The what file? What will cause the OST file to be repopulated? Well, if you you mean like resync everything? I mean, we only do that with a new OST, and once we have everything, it's there. So I can't think of any situations. No, all of that should stay intact. As long as the Outlook client that owns that OST can make a initial connection to the original server, because there's some encoding that we do to tie the OST to that server, they'll be able to open it. That encoding mechanism that we use to tie it moves with the mailbox between servers. So if you move a user's mailbox, not only will it happen online in Exchange 2010, but we don't resync the OST. The only time we do the OST sync is when you're creating a new profile and you're drawing everything down for the first time. Otherwise, the OST should be intact and usable even if your server's down. Yes?
When databases fail over between sites, we've got a lot of our Outlook guys. Casarray, we've got Casarray, that's still up. They still contact that Casarray. We're saying the property that you were talking about earlier about the RPC traffic across sites mean that we don't have to change like DNS entry for that Casarray.
Right. Right. So the question is, how do we handle that, or what's the deal with this RPC, allow cross-site RPC access? So the DNS change that you would do to move clients from one CAS array to another is only going to be done when you're actually doing the data center switchover. Otherwise, if you have a failure, then you've got a choice to make. Now with Update Rollup 3, we actually give you the choice. Before it was, yeah, if Outlook can connect, it's just going to go across. We let you control that now. So that we turn it off by default, which means if Outlook is connecting to CAS and it's turned off and the mailbox is located in a different site, the CAS server will redirect them over to CAS in the other site. If you, however, set the property to true, then Outlook will connect to the local CAS and CAS will talk over the WAN to the mailbox server in the remote site. So the default is false to do the redirection. And if you set it to true, we'll go ahead and talk across the WAN. Correct. The only time you would ever do that is when you're actually switching over the data center. That's the only time you change those DNS entries. Yep. Yes? Yes. Yes. Cause a pop-up and it'll say Outlook needs to be restarted. Well, it's a hey, you've changed your MAPI endpoint. You need to restart kind of thing. Yeah. Yeah, you'll see that pop-up come up, and then the user will know. It'll the generic one. The administrator has made a change to your mailbox that requires you to restart Outlook, is what it'll say. Correct. Correct. Yes. Say that one more time.
Is there any other way that end user could create and modify contacts besides using public folders?
There's no easier way. Public folders are going to be the best way to do it right now. I mean, you could do a shared mailbox, but I don't think that's going to be as easy as just pointing people to a public folder and having the contacts go in there. I sort of knew that follow-up was coming. And yeah, we've had that discussion a few times this week. There's not really a graceful solution to that problem. But it's feedback that we've heard several times this week and that we're taking back with us to our service people to let them know. So for right now, I don't have an answer for you. Maybe that will change one day.
Am I right that after the tool, Microsoft doesn't recommend usually providing use that content?
That's correct. Starting with Service Pack 2 for Exchange 2010, we have advised everybody to no longer use the /hosting switch and use hosting mode. Yes, we want everybody to use the full product now. Hosting mode was a great idea, but the limitations of it became too severe and started impacting the adoption rate. So there was some work that we needed to do in SP2, things like address book policies, for example. and the combination of features that weren't available in hosting mode, since they were available in the full product, some hosters decided just to use the full product anyway. So we decided to say, okay, yeah, I don't think we need to limit you guys anymore. We're going to let you have the full product, and we're going to deprecate hosting mode. So yeah, don't use hosting mode anymore. It's consider it gone, even though it's in there, but consider it gone. Yes?
Normally during maintenance windows, whenever we start doing the cast array maintenance, we start shutting them down. The next Monday or Sunday, we get a lot of tickets from users that their output now is broken.
Authenticate, yep.
We've been trying to find users for users and being right now. They're not using that, so we just only help these things create high volume.
Yep. It's probably which load balancer are you using? Okay, it's a configuration in your load balancer that's not persisting the authentication setting. I don't know what the equivalent would be in Cisco, but you would want to talk to them about that phenomenon. They should be aware of it if they have Exchange experience. It's a common thing. No, it's not. What you could do to sort of get away with it is to drain the connections before you go ahead and shut the services down, because the graceful drain will sort of tell Outlook to gracefully disconnect. No, your load balancer should have a feature that says service all existing connections and then close them out and stop accepting new ones. That's the concept of draining. So you're just finishing up what's left and you're not allowing anything new. So once that endpoint is done servicing that, then you don't have any clients trying to authenticate against that or against a new one after that. But talk with the Cisco folks. They should be able to square you away. If they can't, send me an email and I'll see what I can do to help you out. Time here. Yeah, that has the same effect. The downside to doing that, though, is it severs anything that's happening in process. I've worked in the legal industry, so I know how lawyers can get upset if they're doing something and they click something and the expected thing doesn't happen. So that would work in terms of the behavior, but you might not like the behavior of the lawyers who get disconnected abruptly like that. So good advice, but use it, wisely, as it were. Okay, well, why don't we all reconvene in Hall 7 in a little bit at the Ask the Experts area. And again, please feel free to send me email messages if you have questions later on. Thanks very much for coming.